So trapezoidal rule used to calculate the approximate area of an irregular shape. And what you do is you split the irregular shape into a load of trapeziums, right? That's where it comes from, a trapezoidal rule. So, right, okay, but they're approximate trapeziums, right? Okay, so for example, I'm just going to do one like this, right? We'll just imagine it's a field, right? Okay, and it's got straight edges on 3 sides and there's a wavy edge on the other side. Weird shape, not a rectangle, triangle, whatever. Okay, so what you do is, what they do is they divide it into all these columns, right? And they're equally spaced apart. So they're all a distance of h apart. Now mine don't look very even. I did a very bad job of doing that. So they're all they're all equally spaced, right? So a series of vertical lines which will divide it up like this, and they're all equal. And we call the measurement of those gaps h, right? Is that okay? Right, okay. Then we call the length of the first vertical line y1. We call the length of the second vertical line y2. We call this y3, y4, y5, y6, and y7. Is that okay? Right, there's no set amount of what you call it, vertical lines you should draw. You can draw any amount you want. Okay, the more you draw, the more accurate your answer. Right, remember it's an approximate area, so the more that are in there, the more accurate the answer. Okay, but to be honest, they'll be drawn for you. You won't have to choose how many to draw. Okay, so I'm going to give you the formula and then I'm going to explain how I got there. Okay, but you really don't need to know how I got there, but I'm just going to explain how I got there because it might help with the understanding. So the formula for the area of that shape is h over 2. So h is the measure of this width here. Okay, h over 2, open bracket, times, now in the log tables it's written like this, y1 plus yn plus twice y2 plus y3 plus dot 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 all the way up to yn minus 1. It's in the log tables, and that's how it's written in the log tables, and to me that does make a lot of sense. Okay, so I'll tell you what the short way is that you remember. Okay, so if you want to remember the area rule, it's h over 2 times the first, and by the first means I mean the measure of the first vertical line, right, plus the last, and by the last I mean the measure of the last vertical line, right, plus twice the rest. And by what I mean by that is you add y2 plus y3 plus y4 plus y5 plus y6 and you double them. Okay? Right, and what you're doing, girls, is you're actually you're getting the area of this trapezium, then you're getting the area of this trapezium, then you're getting the area of this trapezium, then this one, then this one, and then this one. Okay, so you see the way this is two parallel lines and the vertical height between them. It's a trapezium turned on its side. So these are the two parallel lines and the perpendicular height between them is h. Okay, so what you're doing is you're getting the area of this trapezium. You're short a little bit. Okay, but on some of the other ones you'll have an extra little bit added in. Okay, so that's where it comes from. That's enough as you need to know about it, right? This is the formula, right? Don't look confused because it's actually very easy. Wait, I put up an example and then you'll see I don't know why I was confused, right? Okay, as I say, that's the way it is in the log tables. This one is way more usable though, if you remember this, okay? Right, so example. find the area of so I say this is 7, this is 8, this is 10, this is 8, and this is 7.5. Okay, and in, we'll say that's 3. Okay, right, and everything's in meters. Okay, so 7 meters, that says 8 meters in case you can't read it, 10 meters, 8 meters, 7.5 meters. Is that okay? Right, so the formula is the area of that shape is h over 2 times the first plus the last plus twice the rest. So h is the measure of this distances. Remember, these are all the same. That's the rule, they have to be all the same. So h is 3 over 2 into, the first is measured, the first vertical line, which is 7, plus the last, which is 7.5. Now you those in, so every line goes in once, right, so they're gone, plus twice the rest. So you add up the ones that are left, 8 plus 10 plus 8, right, and into the calculator and press equals, right, okay, so that's 18, 26, 52, 52, 66.5, 66.5, multiplied, yeah. $99.75. When you work it all out, 99.75, and it's meters squared because it's area. Okay, see what I mean? It's just filling out a formula. Are we good? Right, okay. Yeah, move it over, sorry. Example 2. Am I okay to move it up? I moved it up without asking you. Is that okay that I go with this? So 5, 15, 17, 14, 13, 13. Okay. So this is like there's no straight sides either side. Okay, you can do it all together, right? So you can still make a trapezium, you can still make trapezoids out of these, okay, as in there's one there, there's a trapezium, there's the parallel lines, and the distance between them is the h, so you can still do trapezium, so you can do the whole lot together, right? Okay, so the area is h over 2 times the first plus the last plus twice the rest. Okay, so please note, girls, h over 2, h is 5, so it's 5 over 2. The first is the length of the first vertical line, and I hear you say, what vertical line? So what does the first measure? what vertical line it measures? 0. Okay, there is no vertical line, so there isn't. Right, the last is the last vertical line. Again, I hear you say, what vertical line? Because it measures 0. Right, then twice the rest. So you add 15 plus 17 plus 14 plus 13 plus 13, and you double it and you multiply your answer by 5 over 2. 32, 46, 46 and 39 makes 85. 85 multiplied by 5 would be 425 meters squared. Is that okay? Are we good? So please note, there is no vertical line at the start, there is no vertical line at the end, so the first and last measure 0, right? Common mistake, people put in the 15 as the first. 15 is not the first. They put in 13 as the last. They are not the first or the last, okay? And another common mistake is, once you put in the first and the last, they're gone in, you do not put them away, you do not put them in again here, right? Okay, once they're used, once they're gone in, they're used, so you never put a line in twice, okay? Maybe I'll do one working backwards. Right, okay, example 3. It's not drawn very well. In fact, it's desperate. And this time they tell me the answer. So area equals 17.23 centimeters squared, right? So that's 2, 5.42, 3, 1, 4.36, 3.66. Is that okay? Right, so you fill in, this time we know the answer, right? Okay, we're missing H, so the question is find H. Right? So it's H, area is equal to H over 2 times the first plus the last plus twice the rest. So I know the answer. The answer is 17.23. H I'm missing. Right? First, what does the first measure? 0. What is the last measure? 3.66 plus twice the rest. So this one measures 2, then this is 5.42 plus 3 plus 1 plus 4.36 and that 3.66 is gone in already as the last, so don't put it in again. Okay, multiply out what you can here, so that's 7.42, 7.42, add 8.36, multiply by 2 equals, add 3.66 equals when you work out inside in the bracket, it's h over 2 times 35.22 equals 17.23. Okay, so I'm going to 17.23. I might as well multiply in by a half there, seeing it's on my calculator. Okay, so divided by 2 equals, so that would be 17.61. 17.61 H. So then H is divide 17.23 divided by 17.61. So that would be 0.978. 0.978 centimeters. Is that okay? So just one working backwards. Right, pretty straightforward, yeah? Are we good? Yes? Here I just divided by 17.61. So it's like 3x equals 6 written backwards, and you divide by 3, yeah? Okay, so it was 17.61. Sorry. It was that written backwards. So I just divided by 17.61. Sorry. So how did I get 6? I divided 35. You know, I multiplied inside the bracket. And I just divided it by 2. Because it's h over 2. So I just divided it by 2. Is that right? Sorry. That the answer, they gave it to me. They gave it to me. Right. Any more questions for me? Right. Do you think we're good with the trapezoidal rule? It's just filling in a formula, and you may be asked to work backwards and whatever. Right. Okay. Time. How am I going? Right. I will go back and correct some of last night's homework. I won't get it all done, but I'll get some of it done. I'm happy now that we've the next section done. So I gave you was it 4? Am I doing 4? Anyone need me to do number 4? No? 5? Anyone for 5? No. Then I gave you 7. Anyone for 7? Right, okay, so for number 7, I have a rectangular base prism. Okay, I'll just draw it my own way. Okay, so this is 15 centimeters, this is 10 centimeters, and they give me the perpendicular height there in the middle, which is 14 centimeters. Okay, so the rectangular base point is directly above. Draw 2 different possible nets. Okay, so you could just flatten it out, and here is one. The big triangles are here, and then there's smaller, skinnier ones here. Right, that's one possible net. Another possible net is you just break it apart at a different space. So I might put the 4 triangles right, then there's a fat one. Oh, this is really bad. Then there's a skinny, sorry, fat triangle, right, with a rectangle there. Okay, then you know, I'm going to put the other rectangle there, or triangle, and then there's a skinny one here and a skinny one here. Right, I think there's lots of different possibilities there. You just break it apart at a different point and flatten it out. Okay, right, this one is obviously my favorite one. Right, okay, right, okay. Then it says, I'm going to rub these out now because I want to use the same board with the original diagram so I don't have to draw it again. Can I rub this out? Yeah, I'll take that again. Okay, right, you see the way we have the perpendicular height there? I can make a right angle triangle there. See the way I've made a right angle triangle there? Right? Agreed? Right, you see the slant, the hypotenuse of that right angle triangle is actually the perpendicular height of the triangle at the side, isn't it? Okay, so of that right angle triangle I've just drawn there, this here, the hypotenuse, right, is actually the perpendicular height of the side. You know, when you flatten it out, it would be the perpendicular height. Would you agree? Yeah? Okay, so I know this is 14, right? Okay, and this is half of 15, so that would be 7.5, wouldn't it? That length there. And I can use Pythagoras' theorem, so I can use h squared is equal to 14 squared plus 7.5 squared into the calculator that and get the square root. Has anyone got an answer for me? No. 14. Um, 15.88. So that line there is 15.88, which is really the perpendicular height. If I was to flatten out that triangle there, the perpendicular height of that triangle is 15.88. Yeah? And the base is 10 centimeters. Okay? So the area of this, I'm getting the surface area of the whole lot. So the area of this is half the base by the perpendicular height. So a half the base by the height. So it's a half of 10 by 15.88. So that would be, multiply that by 5. 79.41. Is that okay? I'll see where I've come up with that. So I now have the area of that triangle there, right, and I can double it to get the triangle, the area of the triangle over here. Agreed? Right. Okay, the triangle at the front, right? So this triangle at the front, the perpendicular height of that, it's across 15. So the base is 15, I need the perpendicular height of that, right? If you draw the triangle, right, kind of coming out to face me, right? So there's that, then I draw a line from there to here, and then draw a line up to there. There's a right angle triangle there. Okay, so the perpendicular height is 14. The length from the center out to here would be half of 10, which would be 5. And again, I can get the hypotenuse, right, which will be the perpendicular height of that triangle there. Okay, so I'll go 14 squared plus 25 equals, and square root of the answer equals 14.86. 14.866. Is that alright? Okay, so do you see I've drawn the right angle triangle. It starts in there, then this is out to this line here, so that's that line, and then the hypotenuse is the perpendicular height of that triangle that's facing us. Okay, so get the area of that. It's half the base by the perpendicular height again. So it's a half of 15 by 14.866 into the calculator. With that, press equals, so multiplied by 836.21. That seems very big. That seems very big compared to the other one. I'm thinking, did I multiply it right? So it's 14.866 multiplied by 7.5 equals, yeah, 111.49. That makes more sense. Is that okay? I don't know what I did. I think I multiplied it twice or something. Are we good? Right, does everyone see where I am? Right, I need to get the surface area of the whole shape. So the whole shape, there's two of these triangles. So it's 2 times 79.41 plus 2 of the fat triangles, 2 times 111.49. And there's also the rectangle at the bottom, which the rectangle at the bottom would be 10 by 15. Into the calculator with that and press equals, and there's your answer, and you have to round it up. No. You didn't want to identify that they don't say give your answer correct, so I give 2 places decimals if they don't tell me. Right, okay, are we good? Right, any questions? No? Right, okay, we've all lost the will to live again. And you were going so well. Right, okay, I'll get one more done. 10, is 10 the next one? I think it is it? Right, will I do 10? Right, okay. Before I start, I kind of alluded to this yesterday. This is the question I was heading for. If you want to get the volume, right, you know, the volume of a rectangular is length by width by height. Would you agree? So it's 3 lengths multiplied by each other. So you'll end up with a length to the power of 3. Yeah? Okay, if you were to get the volume of a cylinder, it would be pi r squared h. Don't worry about the pi, but the radius is a length by a length, isn't it? It's a length by a length, and a height is another length. So that would be a length to the power of 3 again, wouldn't it? Right, you know the volume of a sphere is 4/3 pi r to the power of 3. Again, don't worry about the constants. R to the power of 3 is a length by a length by a length. So that's a length by to the power of 3. Agreed? So basically, if you're talking about a volume, there has to be a length to the power of 3 in there somewhere. Okay? Area, right, if you're talking about the area of a rectangle, it's a length by a width. So you're talking about multiplying 2 lengths together. Is that right? Okay, if you're getting the area of a circle, it would be pi r squared. So it's a radius by a radius, which is a length to the power of 2. Agreed? Right, area of, give me another shape, I can't think of one. A triangle is a half the base by the height. Right, a base is a length, a height is a length, so you're basically multiplying 2 lengths together. Right? So anytime you're getting an area, you're multiplying 2 lengths by each other. Okay, would you agree? Right, so that's what question 10 is about. Right, okay, so if it's a volume, there should be 3 lengths in there multiplied by each other. Right, if it's an area, it should be 2 lengths in there multiplied by each other. And they're saying, right, they're saying that there's 3 lengths here, x, y, and z. So x by y by z, right? Or it could be x by z. Or it could be x by, do you know, there has to be 3 of them in there, right? Okay, so the area multiplied by a length. So the area multiplied by a length, what will that give you? Area multiplied by length is a volume, isn't it? Yeah, sorry. So area multiplied by length, that's a volume, isn't it, on the left-hand side? A length, 3 lengths multiplied by each other, that's also a volume, isn't it? So is that consistent? Could that work? Yeah, that could definitely work. Right, next one. X, which is a length. So if you take a volume, which is L to the power of 3, isn't it? And take an area by a length. So L to the power of 2 by L. So you're basically L cubed divided by an L cubed. Will you end up with a length? No, you won't. So that's inconsistent. Right, okay, thought that happened really fast. I'll come back to those, I haven't forgotten about them. Homework, page 184, 1 to 6. Page 184, 1 to 6.